And I assume we are recording now. Okay. I did assign a homework today. And I'm gonna give you an exam online. So I will upload it on the midterm one. And you submit it the same way you did with the homework, but it's an individual work. How about if I give it to you on a Friday morning, like 10 o'clock, and you give it to me by 6 o'clock? Or do you want it on Saturday? Hello? So not everybody is logging in. I only have 7 people. So the exam, I will send an announcement on Canvas today. Well, some people are saying Friday, some people are saying Saturday. So I don't know. For the person who said Friday, is it absolutely you cannot do Saturday? Oh, somebody's out of town this weekend. Okay. How many can they not do? You cannot do on Saturday? I need a reply. Okay, so let me read my messages. Uh, Peyton. All right, so 2 people cannot do Saturday. So for these 2 people, I will email you. Okay, so it seems like the exam is going to be on Saturday, but for 2 people who are going to be out of town, I will email it to you on a Friday, and then you will submit it to me by 6 o'clock on a Friday, okay? You will send it to me by email. So for those 2 people, I will send you the exam on a Friday by email, and you give it back to me through an email. Okay? All right. So do you mind if I mention the names? Because a lot of people who's telling me they cannot do it on a Friday, they think I'm going to do it to them on a Friday. Do you mind for those people who cannot do Friday, I mention their name? Okay. So it's Erin Millhouse and Peyton cannot do Friday. So you 2 will have the luxury of receiving the exam on a Friday. Maybe how early do you want it? Can you do 8 o'clock on a Friday? Oops. Who cannot do on Saturday now?
I think you just misspoke.
All right, tell me what. Tell me, how did I misspeak?
Well, you just said that you were talking about Aaron and I, we can't do it on
Friday.
Saturday.
Saturday, yes.
Yeah, we can do it on Friday.
You can, right?
Yes, yeah, can.
So you 2 will receive the exam on a Friday. You only 2. Okay?
Sounds good. Eight works.
And the rest will do the exam on Canvas on Saturday. Okay? All right. I assume this is what we're gonna do.
So we're talking about 19th, right, Professor? Sorry, I missed the first 2 minutes of the class.
Yes, this Saturday. You're gonna be out of town?
Yeah, that's what I told you on the last class, that I will be out of town from 16 to 19.
16 to the 19. What is the 19?
19 is Saturday, basically. So that's why we did not have class on Friday and Saturday. That's why I think that it would be better to travel on the weekend.
Right. So are you available on a Friday?
Actually, I'm going to drop off my parents from like Tennessee to Atlanta, so I'll be probably somewhere in between. Their flight is on Friday, so
Okay. So you cannot do Friday. Is that what you're saying?
yeah.
Friday and the weekend you cannot do, right?
I can do it on Sunday if you allow me to.
All right. Let's put the question the following way. Does everybody have a problem doing the exam on Sunday? I know the one that cannot do the weekend. I know you will get it on a Friday, but can you do it on Sunday? Will you be back home to be able to do it on Sunday?
Yeah, I'll be coming back home on Saturday actually, so I can make it on Sunday. I'm fine with Sunday.
Okay. So if anybody cannot do Sunday, please email me. Aaron and Peyton, I know you can only do Friday. I will do it on a Friday. But so the Saturday date is moved to Sunday. So Aaron, can you do Sunday now?
Yeah, Sunday will be better for Peyton and I, honestly.
Okay, well, I can do Sunday. So that means Sunday for everybody, right? Okay, your exam is on Sunday. I'm sorry if you have a religious holiday. I do go to church on Sunday too. So if that is, you don't have to talk to me now, but if this is an individual issue, please let me know that you cannot do the exam on Sunday. Okay, I will make an announcement that the exam will be done on Sunday. Everybody should read the announcement on Canvas. And if you want to email me personally that you have an issue with the date, please let me know. And this issue is over. All right. Any questions? I did assign homework today. And again, I glance. So I'm spending about 1 hour on your homework. I glance through it. And if you're putting the effort, I'll give you a complete grade. It's not a big deal for me. All right. Any questions? Okay. All right. So we're going to be in chapter 3. This is going to have to go. Let me get it better. This is called Z transform. So basically, Z transform is the analogous actually of, can you tell me what it is? Of Laplace transform. Okay. So the Z transform is analogous to the Laplace transform. All right. So again, the transform is the discrete analog of Laplace transform. Okay. Recall if you have f that is defined on R through R, then the Laplace transform, I'm not going to go into the detail now, is 0 to infinity e to the minus st f of t dt. And we usually look at it as f of s. Okay? So that is the Laplace transform of a function of a function. Doesn't have to be continuous as long as it is defined. So the function does not need to be continuous as long as it's defined and this limit exists. Then that is because this is an improper integral. Okay, so that is the definition of a Laplace transform. So now we're gonna define the Z transform. Okay, so if you have a signal now, if you have a digital, digital signals or a discrete signal, how do you find the Z transform? Okay. I keep losing my notes. First of all, we need a definition. Definition 3.1.1. Okay? A sequence xn is said to be of exponential order if there exists a number R that is positive and an integer n, again positive, such that xn less or equal to R times c to power n, and this is for all n bigger than n. So this is what it means, and where c positive is a suitable constant. Okay? So that is the definition of exponential order. So for example, if you have xn is a to power n, a is in R, then xn is less or equal to a to power n, which is the same of c r to power n. Here c is 1 and r is a. And this is, so that is of exponential order. Okay? Oh, rc to the n. Oh, I got it backward. Sorry. rc to power n. Is that what I have in my note? Yeah. So here, r is 1 and c is absolute value of a. So that is of exponential order. On the other hand, xn is n factorial, n belong to n is not of exponential order. Okay? So that is not of exponential order. All right? This is n factorial. All right. So it does not mean every sequence is exponential order. And here, for example, in this example, a could be bigger than 1. You see the limit as n, as the limit of that goes to infinity. Okay. But I don't care if the limit goes to infinity. But some are controllable, some are not, like n factorial is not. So therefore, we shall see that n factorial does not have a z transform. And in the continuous case, there are a similar issue too. All right. Any questions? Okay. So definition, this is the z transform. Okay. The z transform, and I'm going to write it z xn of a sequence xn where that is of exponential order is given by z of xn. Let's write a bracket here because sometimes we may have complicated things. And that is equal to n equals 0 to infinity xn z to minus n, and for z bigger of some number of rows. Recall, let's say f of t in the continuous case is 0 to infinity e to the minus st f of t dt. And look at it. So this is 0 to infinity e to the minus s to power t f of t dt. And you may look at this z as e to the s, or, okay? So all right, any questions? All right. And this function can be called, like here, we called it f of s, and here we may write the function is x, so we may write x of z is equal to z of xn, and that is n equals 0 to infinity xn z to minus n. So we may write big X of z, whatever you want to call it. So this is the large X. You may go like this, but sometimes I may not. So anytime I write like this, that means this is a z transform. There is a z in here, like there is an s in here. Okay? Any questions? Well, why do we need Z absolute value bigger than rho? Because we want this series to converge. And if this series, so that means it has a radius of convergence because Xn is the thing, here the variables. So we're gonna do a couple of questions. So next, what I'm gonna do is the following. Okay, it says theorem 3.1.1. Suppose the sequence Xn is of exponential order, then its Z transform exists. Proof. Well, Xn is of exponential order means there is an n star, a positive, such that Xn less or equal to RCn for all n bigger than n star. You remember the definition. Now, then the Z of Xn is n equals 0 to infinity Xn Z minus n. I'm gonna go n equals 0 to n star minus 1 Xn Z minus n, a plus n equal n star to infinity Xn Z minus n. Okay? And so now n equals 0 to n star minus 1 Xn Z minus n is finite since it is summed over finite interval. Okay? Now we need to worry about this one. On the other hand, n equal to n star to infinity Xn Z minus n is less or equal to n equal to n star to infinity Xn Z minus n which is equal to n equals star to infinity of Xn over Z, okay, Z to power n for n bigger or equal to n star, this is less or equal n equal to n star to infinity. Xn is less or equal to r c to power n of z to power n, and that is r n equal to n star to infinity c over z to power n. Okay? Do you see what happened? Notice here, so, and this is converges since z is less than c. Okay? All right. No, sorry, z is bigger than c. Z bigger than c. Or 1 over z is less than 1. Okay? So basically, this completes the proof for the 2-year-old. All right. Any questions? Okay, let's do a couple examples. All right. Now, when we define z of xn equal n equals 0 to infinity, xn z to the minus n, or z bigger some rho, okay? That means the sequence xn is defined to be xn for n bigger or equal to 0 and 0 for n less than 0. This is what it's defined, how it's defined. Because if I go zxn n equal minus infinity to infinity, xn z minus n, then this is the full z transform. If I have this one, if I have xn 0 for less, then I will have this one. But in this code, this is what we're gonna be using. Like, because we're doing the discrete analog of Laplace transform. Okay? Any questions? So this is called the full Z transform. Now, if I let this is x of z equal to n equal minus infinity to infinity, xn z minus n. So if I let z equal to e to the j omega, then I have x e to the j omega is n equal minus infinity to infinity okay, xn e to the j minus nj omega. And this is the discrete Fourier transform. Fourier transform, which is we are not going to talk about it here. So I'm just letting you know that Z transform is more general than the Fourier, than the Fourier transform, discrete Fourier transform. Okay, because you let Z equal e to the j omega, omega some frequency here, and then you will get the discrete Fourier transform. Okay. So if you have two sequences, AN and BN, with AZ, BZ, these are their corresponding Laplace transform. Then that means AN equal to BN. So if you have two sequences with the same Z transform, then those sequences are the same. Okay? Or vice versa, and vice versa. All right. Okay. So let's do standard. This is section 3.2. Standard function. That means the Z transform of the standard function. In the sense that, like in Laplace transform differential equation, you found the Laplace transform of a constant. You find the Laplace transform of exponential, of sine, of cosine, and we're gonna do the same here. Okay, that's what we are trying to do. Any questions? Okay. So let's start with linearity theorem. Okay. Let's say we have two sequences. UN and VN, and constant C1 and C2, then the Z transform of C1 UN plus or minus C2 VN is equal to C1 Z of UN plus or minus C2 Z of Vn. Okay? All right, here's the proof. Well, Z of C1 UN plus minus C2 Vn is equal to n equals 0 to infinity of C1 UN plus or minus C2 Vn Z to power minus n. Distribute. That is C1 un z to power minus n plus minus C2 Vn z to power minus n. That is C1 un z minus n plus minus C2 Vn z minus n. Okay? And that is equal to C1 z of un plus C2 z of Vn. And now z is bigger than the max of row 1 or row 2. Because remember, the two sequences have, so what we are saying is, we're saying at the beginning, we looked at ZUN, C1 is defined for Z bigger than row 1, and Z of C2 Vn is defined for Z bigger than row 2. So when you add them, this is from the definition that the Z transform of U and V exists. So each one of them has a different radius of convergence. So when you combine the two, the radius of convergence has to be the max than row 1, row 2. Okay? Any questions? And this is the remark. So basically, see remark 3.1. All right? So go ahead and read it. See if you have any question about it. Now let us divide, do some formulas like we did before. So 1, let's calculate ZA to the n. A is different than 1 and 0. Okay? So what is that? That is equal to n equals 0 to infinity an z minus n. Okay? So that is n equals 0 to infinity A over Z to power N, right? And that is 1 plus A over Z plus A over Z squared plus AN over ZN continue, and that is 1 over 1 minus A over Z, provided that A over Z is less than 1. Because this series sums to that. This is a geometric series. And this one simplifies to Z over Z minus A, provided that Z is bigger than A, or the absolute value. And that is the radius of convergence. Okay? So for example, if you want Z2 to power N, that is Z over Z minus 2, and we have Z is bigger than 2 in order for that to converge. Okay? Any questions? Recall e to the AT, e to the T, e to the AT is 1 over S minus A, provided that S is bigger than A. That is the Laplace transform. Okay? Remember? And you can compare the two. All right? Or here, may I say e to the BT. Well, actually, let me keep it e to the A so you can see the difference between the two. All right? All right. So that is the difference between the Laplace and the Z transform. 2, if B is constant, then I'm gonna find the Z transform of B. Then that is n equals 0 to infinity B times Z to the power minus N. And that is B n equals 0 to infinity 1 over Z to power N. And let's set A equal 1 here. If I set A equal 1, I get B of Z over Z minus 1, and that is BZ over Z minus 1, provided that Z is bigger than 1. Okay? Any questions? How to compute the Z transform now? Now let us find, any questions? Next, we find z of cosine n theta and z of sine n theta. So we're gonna do them all at once, okay? We're gonna get both of them at once using Euler formula. Oh, excuse me. So first of all, note that e to the minus e to the I zeta equal to so now let equal to let c equal to minus n theta. Okay. Then e to the minus I n theta is cosine minus n theta plus I sine minus n theta. And that is cosine n theta minus I sine n theta. Correct? But we will get back to that later. Okay. Now let us find z of e to the minus I n theta. Let's find z of that, the z transform. Let's use the definition. So that is our xn. That is n equals 0 to infinity. Okay. E to the minus I theta to power n. Okay. And so that is by formula A, remember z a to power n is z over z minus a, z bigger than a, right? And so if I use this is a, so this is gonna be z over z minus e to the minus I theta. And this is z over z minus e to the minus I theta times z minus e to the I theta over z minus e to the I theta. Are you okay with that? So this is z times z minus e to the I theta over the bottom. The bottom is gonna be z squared minus z e to the I theta minus e to the minus I theta plus 1. Why is that? So you're going to have z squared minus z e to the I theta. There you go. Minus z e to the minus I theta. There you go. Okay. So that will be a plus. And then e to the minus I theta minus minus, that will be plus 1. Okay. Oh, sorry, this is a plus, which is good because I need it to be plus. All right. We do recall that that cosine theta, okay, is e to the I theta plus e to the minus I theta divided by 2. Okay. So this one is z times z minus, what is e to the I theta? Is minus cosine theta minus I sine theta. And this in the bottom, this is z squared. Now e to the I theta plus e to the minus I theta is 2 cosine theta plus minus 2z cosine theta plus 1. So what have we shown yet so far? Now notice, so far what we have done is, so far z of e to the minus I n theta is z of cosine n theta minus I sine n theta. This is what we have so far, because we know this one is that. So let's go back down to here. That is z, okay? That is z times z minus cosine theta over z squared minus 2z cosine theta plus 1 minus I, okay, minus I z sine theta over z squared minus 2z cosine theta plus 1. Okay. So let's take a look. All right, so you notice, so by the linearity theorem, so basically what I have is, sorry, this is big Z. So Z of cosine n theta minus, how do I, yeah, minus I Z of sine theta is equal to Z times Z minus cosine theta over Z squared minus 2Z cosine theta plus 1 minus I of Z sine theta over Z squared minus 2Z cosine theta plus 1. So by the linearity theorem, we have, okay, let me get rid of this. We have oh, this is totally bad. Z of cosine and theta is equal to that one over Z squared minus 2Z cosine theta plus 1 and Z of sine n theta is Z sine theta over V squared minus 2Z cosine theta plus 1. There you go. So this is the formula. This is the formula, and this is the formula. Okay? Any questions? You see what we did? Think about it for a second. And forgot to mention that the radius of convergence is bigger than 1. Okay? for the cosine theta. So these are two formulas that we did. So let's do an example, then we can take a time off. What is z of minus 1 to the n? Okay. So basically here a is minus 1. So we are looking at za to power n. That is z over z minus 1. Z bigger than 1. So here a is negative 1. And so z of minus 1 to the n is z, oh, sorry, z minus a here. Is z minus 1, and that is equal z over z plus 1 over z bigger than 1. Okay? This is like finding the Laplace transform of e to the minus t. You see, this is what it is like. Okay. So let's say we want to find z sine n pi over 4 plus 4 times a to power 7. So that is equal z sine n pi over 4 plus 4 za to power 7. Okay? It's not that important. So this is actually, I may just to write z of 1, and that is sine n pi over 4. So theta so here the angle is pi over 4. So it's gonna be z sine pi over 4 over z squared minus 2z cosine pi over 4 plus 1 plus 4a to power 7 times z over z minus 1. Okay. Now sine pi over 4 is the square root of 2 divided by 2. You can rearrange it. All right. Let's take 5 minutes break and come back. You should have that. Otherwise, I'll have it out of the mouth. I did, so strong, taste so strong. Now, I mean, you are ready? You don't like the taste so strong? It is. This one, tasty than the rest. All right, I'm back. Okay, any questions? All right. Now we have definition. And this is definition 3.2.1. A, the unit step sequence U of n, it's like the funny U, is defined by U of n equals 0 for n less than 0 and 1 for n bigger or equal to 0. So basically what this is, if this is n and this is u, at n equals 0, we have 1, 1, 1, 1, 1. This is 1, 2, 3, 4, 5, and so forth. And it is 0, 0, 0, 0, 0. And as you can see, this is 1. Okay? And then B, the unit impulse sequence delta n is defined by delta n is 1 for n equals 0 and 0 for n not 0. So basically, it is 1 here and it's 0 everywhere. Okay, that is the delta n, and that is n. So it's basically at n equals 0, it is 1, and then it goes down to 0. Okay. Note that as a consequence of B, we have k equal minus infinity to infinity, delta k, you know, it is 0 everywhere. It is 0 plus, it is 0 plus 0 plus, and then delta of 0 and plus 0 plus 0, and that is 0 plus, what is delta 0 here for n equals 0? 1 plus 0, and that is equal to 1. So the sum for the impulse function from minus infinity to infinity is 1. And in general, k equal minus infinity to infinity, ak delta k for any sequence that is 0 plus 0 or plus k equals 0, a 0 del 0 plus 0 plus that is a 0 del 0, that is a 0 del 1, and that is a 0, because del 1 is 1. Del 0 is 0 is 1. Okay? Okay? They shifted the shifted impulse function del k of n is defined by 1 if n equal k and 0 if n different from k. So basically what it is let's say n equal k will be 0 everywhere. So if you look at this picture, usually we defined it to be 0 to be 1 here. But now if this is k, it is 1 here and 0 everywhere else. You see that? It's only 1 here. And that is 1. So you shift where the delta function is. And this is, I give you an example, see exercise. See exercise 3.1. Okay? Now, so if we multiply, so if we multiply an by the time shifted impulse, by the time shifted impulse function del k of n, then we get a signal that is 0 everywhere except at n equal k, where it takes the value ak. So that means if you do an delta k of n, that is ak delta k of n, because there is only contribution when n equal to k, and hence AN is K equal minus infinity to infinity AK delta K of N. Okay? That is a very important observation here. All right? So now we're gonna find. So what is the unit step function of UN? Remember what UN is. UN was 0 for n less than 0 and 1 for n bigger or equal to 0. So let's find the Z transform of it. What do you think we're gonna get? That is n equals 0 to infinity of UN Z minus n, and this has the only contribution is 1. So that is Z over Z minus 1. Okay? Z bigger than 1. What about Z of delta n? Well, again, that is n equals 0 to infinity delta n Z minus n. But this is equal to 1 only at n equals 0, and that's it. That is delta of 0 Z minus 0, and that is delta of 0, and that is 1. So the Z transform of the impulse function is 1. Okay? All right, I think I'm gonna stop here for today. You have a couple big homework to do. Please start working on it. And tomorrow I will let you know what the exam is gonna be over. All right, for next Sunday. Do you guys have any questions for me? Any questions?
Yeah, Professor, so you're assigning it on Sunday. Is it like
Yes.
gonna be available from 8 a.m. to like what's the timeline?
I will send an announcement today on Canvas. Where is a good time for you guys? I mean, some people are sleep late. I don't know on Sunday. So let me give you 1 hour to hear back from you. And if there's no constraint, that I will make it at 8 o'clock on Sunday. Okay.
And then is it like, do we have like a class period to do it? Like like hour 40 or 2 hours or all day? What's like the?
I'm gonna give you 8 hours. It's
Oh,
gonna be a
okay.
regular exam. Okay.
All right.
I'm gonna give you 8 hours. I will count whenever we start the exam. Okay. Any
That
other
works with
questions?
me.
All right. You guys be safe. Talk to you later. Somebody had a question. Let me read it first. Okay. When can I think that's okay. That's all I have for now. Okay, I'm gonna stop recording.